Hi Algebra 2, I'm going to take you through some notes on concept 25, logarithms and logarithmic functions. So look in the middle of your note sheet, right here at this graphic. So you know that 2 squared equals 4 and 2 to the third power equals 8, but for what value of x does 2 to the x equal 6? Up until now, we have not had a way to solve for a variable that is in the exponent, except just by guessing and checking. So this new function called a logarithm allows us to solve for this. So this is some math that was developed. So this is a way a logarithm works. If b to the x equals y, so that's an exponential, then from that exponential, the logarithm that goes with it is log base b of y equals x. So notice that now the exponent from our first equation is what a logarithm equals. So a logarithm is a function whose value equals an exponent. The way that you read it is you put your eyes on the top of the log here, right here. And then you're going to drop your eyes down, and the number that you hit first, that is the base. And then you swing around on the other side of the equal sign, and this is the power, because a logarithm equals a power. And then you come back almost to the beginning, and that equals a value. And so you can see that this is the exponential that we started with. So a logarithm is a function that rewrites an exponential so that it is solved for the exponent. Here, there's our exponent. Now the way that you can read a logarithm, just say it out loud, is log base b of y. And if we were to finish that with the equation, it would be log base b of y equals x. Okay, now go back to the exploration. You're going to work on your own since you're listening to this video, and I want you to find the value of x in each exponential equation. And you don't need to explain your reasoning. Then use the value of x to rewrite that exponential in its equivalent log form, where the function is equal to the exponent. So pause the video and do that now, and then come back and check your work. Let's go through these together. Pause the video and write things down as you need to. So number 1, 2 to the x equals 8. Well, x is going to equal 3. Now written as a logarithm, you would write that as log base 2 of 8 equals 3. So if you think of the motion of a logarithm, you start up top and it's 2. You come around because a logarithm equals the power. 2 to the third power is 8. On b, we have 3 to some power equals 9. Well, of course, that power is 2. So written as a logarithm, we would say log base 3 of 9 equals 2, which means 3 to the second power is 9. But remember, a logarithm is going to equal the exponent. That is in the line of the equation. For c, x will be 1/2. A little tricky. You just have to think in terms of all the possibilities for exponents because the square root of 4 is 2. So written as a logarithm, it's log base 4 of 1/2 is 2. d, 5 to some power is 1. Well, it's 0. So written as a logarithm, log base 5 of 1 equals 0. Or 5 to the 0 power equals 1. 5 to what power would be 1/5? Well, -1, because that will flip it. It's reciprocal to the first power. So log base 5 of a fifth equals -1. And that's how you make sure that you have the logarithm written with all the numbers in the right place. Now the last one, a little tricky to figure out, but again, if you think in terms of rational exponents, if we take the third root of 8 and then square it, we will get 4. So x is 2/3, and then written as a logarithm, log base 8 of 4 equals 2/3, or 8 to the 2/3 power equals 4. Now go to example 1, and let's write some logarithms together, because that might have been a struggle just trying those on your own. So we have log base 2 of 32 equals 5. Now these are true statements. We're not solving anything. We're just rewriting into exponent form. So we're going to read this log using that swing around motion. So 2, we're going to come around to the exponent and then back to the value. So 2 to the 5th power equals 32, and that's a true statement. So 7 to the 0 power equals 1. So log base 7 of 1 equals 0, that's what that is saying. Log base 6 of 6 equals 1, and so written as an exponent, 6 to the 1st power equals 6. And then lastly, log base 1/4 to the -1 is 4. I'm going to go ahead and put that 1/4 in a parentheses. Now you may be thinking, why the word logarithm? So in the word stem and logarithm is logos, which means word or name or term. And so the mathematician that developed this logarithm, named it. It's just basically, I think, using that to name the exponent. So a logarithm is a function that names the exponent by setting that the value that it's equal to, that is the exponent. All right, let's try a few more, okay? Why don't you pause your video now and see if you can do the next 4, and then come back and check your work. All right, check your answers to 1 through 4 and make sure that you have rewritten those logarithmic equations correctly as exponentials. And now let's look at example 2. We're going to work the other way. So we're going to take an exponential and we're going to build logarithms. So we're going to start with log, L-O-G, and then our base will be subscripted. Our power will go on the right side of the equal sign, and then our value will go in the line of the equation. So make sure that you have all of these things written in what I call the line of the equation, and then the base is subscripted, so it needs to be clearly dropped below. All right, this is saying a log base 10 equals 1/10, and our power is -1. Once I write a logarithm, I always, with my eyes, do the swing around motion just to make sure that I have all my numbers in the correct spot and that my logarithm equals my exponent. All right, so 8 to the 1/3 power equals 2, which is, the cube root of 8. So that would be log base 8 of 2 equals 1/3. And again, just make sure you've got your log and the value and the exponent in the line of the equation. And your base needs to be subscripted. All right, so finally, log base 6 of, when I have any kind of something other than a single number or variable, for a log value, I always put it in a parentheses, just because it's easier to, tell what's part of what. So 6 to the -3rd equals 1/216th, and that's how it would be written as a logarithm. All right, now you try numbers 5 through 8 on your own. Pause the video and then come back and check your work. All right, so numbers 5 through 8, those are the answers. So just check your logarithms and make sure you have those written with all your values in the correct places. All right, so let's continue. So logarithm of 1 and then logarithm of b with base b. So this is just saying log base b of 1 equals 0, because anything to the 0 power equals 1 except 0, of course. And then log base b of b equals 1. So anything raised to the 1st power equals itself. Now here, notice that we don't have complete equations or thoughts. We just have a log expression. So we are missing the power. We're missing what the logarithm equals. So we're going to figure that out. Some of these, I think actually all of them, we'll figure out together in our head. So this is saying 4 raised to some power equals 64. Well, we noted the second power is 16, so if we raise it to the third power, that will give us 64. So we simply just write 3 because the value of log base 4 of 64 is 3. Now, some power that we can raise 5 to will give us 2/10. So we know that if we raise, so that means it's a fractional amount. So we need to have a negative exponent. And if we raise 5 to the negative 1 power, that is 1/5. But if we put that as tenths, that would be 2/10. Now, 1/5 raised to some power will equal 125. So my base is a fraction, and then my value is a integer, a whole number. So that means my power needs to be negative because I need to flip that fraction so that my 5 is in the numerator. And then I know that 5 to the third power is 125. Now finally, log base 36 of 6. So I'm going from the number 36 to a smaller number 6. So power-wise, that means I'm going to need to think about roots. So what root of 36 is 6? Well, the square root, which as a power would be to the 1/2 power. Now there are two certain kinds of logarithms that are used often. And one is called the common log, and that has a base 10. We use it so often that if you see a logarithm without a value written, then you can assume that it is base 10. So here, the common log has a base 10. And so if you just see log x, and x is in the line of the equation, you can assume, let me give a little more space here, that this would be base 10. The other type of logarithm is called a natural logarithm, and this has a base e, Euler's number. So log base e of x would be the natural log, or log naturel. It's ln and then x. So you can always assume when you see ln natural log that it has a base e. And then for a common log, if you see log and no base, you can always assume that that is base 10. That's called the common log. So let's evaluate a couple of these, and you're going to use your calculator. So locate the log and the natural log button on your calculator. So for A, you're going to find the log of 8. So what that means is that you are finding the power that you can raise 10 to that will give you 8. Well, it's going to be approximate, and let's go to 3 decimal places. So press your log and put in your numbers, and you should get 0.903 approximately. Now let's take the natural log of 3/10. So what you're doing when you find this is you're figuring out what power you can raise e to approximately that will give you 3/10. Well, we know it's going to be negative because 3/10 is less than the value of e, 2.72 approximately. And so to 3 decimal places, it'll be negative 0.204. Last thing that we're going to go through on this set of notes is the next example, which is finding the inverse of a log or an exponential. Excuse me. So we're going to find an inverse using the steps that we have before. An inverse function undoes the original function. And so we will start by just exchanging our variables, our inputs and our outputs. And then we need to solve for y. So in order to get y out of the exponent location, we need to rewrite it as a logarithm. So we write log, and then our base is 6. The power is y, and the value is x. So our inverse function of that exponential 6 to the x is log base 6 of x. The inverse of an exponential will always be a logarithm, and the inverse of a logarithm will always be an exponential. So let's try B. So the first thing is we're going to interchange our x and y. Now I'm going to put this log expression on the left side of the equal sign. I'm just going to interchange sides. Now I know that a natural log is of understood base e. So to rewrite that in exponential form, this is e to the x power equals y plus 3. And now I get that y value out of the logarithm expression and into the line of the equation. Then I'm going to subtract 3 from both sides. So my inverse function of the natural log of x plus 3 is e to the x power minus 3. And I can just write that inverse function notation. So notice that my minus 3 is in the line of the equation and is not up in the exponent. So here's a note: when you are finding the inverse of an exponential or a logarithm, you're going to interchange the x's and y's and then switch forms. So if you start with an exponential, you're going to rewrite it as a logarithm. If you start with a logarithm, you're going to rewrite it as an exponential. All right, that concludes our Concept 25 notes. You are ready to do the Concept 25 Math Excel practice, and I'll see you tomorrow, and we'll do the next bit of notes on logarithms.